This is Deepti Diwan, a research scholar at Bayani Girls College. Today what I'll going to discuss bit a new topic for you, but the name is the bystander effect. Let me elaborate. It's a non-targeted effects of ionizing radiations. So you can see this is one of my thesis topic. I did it Jawaharlal Nehru University, New Delhi. Bystander effect. Let us have little bit idea about the bystander effect. Imagine a student sitting in a class and lecturer enters into the class and he throws an orange in the classroom and the classroom is dark. What will the result of it? What do you think? Yes, the people try to protect themselves, in turn injuring their neighbors. So the amount of orange thrown is not directly proportional to the amount that is thrown in the classroom. This is a brief idea about the bystander effect. You can see over here the radiation is affecting a single cell, that is a target cell, followed by when the cell is damaged, the other cells are being affected. How? Look, this is how the other cells are being affected with the target cell. That means this red color, that is the target cell, is being affected by a radiation. This radiation is a gamma radiation, and this is affected, that is it is mutated. This mutated cell is now affecting the neighboring cells. So some of its mutation or some of its damaging effects are transferred to its neighboring cells. Now this effect is being transferred to other cells, but the amount is less in comparison to the neighboring cells in comparison to the far cells. So this is bystander cell. If cell has its capacity to damage itself, either this target cells damage it, mutate itself and goes to the cell death phase, otherwise it will affect the neighboring cell, thereby creating chromosomal aberrations, any other DNA damaging effects. There are two types of bystander effect, that is targeted or non-targeted. In targeted, we have the radiation that is directly affecting the cells. That means it is affecting directly the macromolecule. In non-targeted effects, we have a radiations like radiations are not affecting the cells, interacting with the molecular water, cellular water, leading to the hydrolysis of water, producing two molecules, hydroxyl molecule. One is hydrogen, another is hydroxyl. So this hydroxyl is accumulating in the cell, forming the peroxide hydroxyl molecule. Now these are again combining, are becoming dysfunctioning now. This is what the effect of indirected radiation, that is bystander effect. There are two theories, past and hit theory, that is present theory. Past, you know, the hit theory, if the cell is targeted, the cell dies. In the present theory, I have already mentioned in the previous slides, that is bystander effect. What I talk about aims and objectives of my project is I have taken two samples, that is allium sippa, what you call it in a normal language as onion, mung vigna radiata, that is mung bean seeds. These are the instruments used when I did my experimentation. One of them is gamma chamber. This is most popular one, and it has some of the limitations of its use. So while using this chamber, we need to take some precautions when we are performing experiment protocols. So these were some of the news that were highlighted when I was doing my project, that in Delhi University this radiation has leaked and it has affected many of the people, and therefore other people had died because of these radiations. So it was a big scandal at that time. What material method? Already mentioned. So how to grow allium bulb? You can take a beaker, you can put the onion bulbs, allow it to grow, its root grow to 2 to 3 mm, followed by vigna radiata, same, let them to sprout for 1 or 2 days, give them proper nourishment so that the sprouting is good. What DNA damage estimation we did with a Fulgen staining or Fulgen, what you call it as. This staining is very popular for the DNA. So this is the protocol exactly followed for this. Another one was what exactly the difference we have got in the radiations is. Here I am comparing three samples, that is one is control, another one is radiated one, that is 50 gray treated, and another is again 100 gray treated, a higher dose. So the control, the shoot growth is very good when we compare this control with the radiated parts. These parts are divided into two halves. That is, one is radiation treated, other is bystander half. That is, it is not directly treated with the radiation, but the half that is treated with directly with the radiation is combined using a tape or an adhesive and kept in a beaker. So the radiation part shows a very slight growth in the shoot in comparison to the other one that is showing a good growth if we compare it with the control. In the 100 gray radiation dose, the growth is less, or you can say negligible growth in the part. Therefore, what we can say, yes, radiation are some or the other how affecting the growth of the onion shoot tips. Same experiment is done for the roots as well. The control again shows a growth. These again parts are divided into two in the very similar way as it is done in shoots, but the difference is here we are comparing with the roots. So this slide also says that yes, radiations have some or the other effect on the growth of the plant. Now what comparison we did here, the growth, what I had explained in my earlier slides is a graph of 3 independent experiments. See, 9.33% growth is seen over here, whereas 2.3% approximately the growth has fallen in comparison to control. That is a bystander part. This is indirect radiations. So here this is a directly radiated part of I was discussing about effect on cell division. So the growth when you compare with the radiation, it's approximately 3% difference. So it's after 24 hours, it's a big difference. The difference in comparison to radiation after 100 gray radiation dose and 50 gray radiation dose. Direct dose is very bent in the graph. The difference is big in comparison to control. But here we are comparing with the bystander cells. Approximately 2 to 3% difference in both, either a 50 gray or a 100 gray. So now this is another sample, Vigna radiata, mung bean. This is 0 hour. That means immediately after radiation, followed by 24 hours and 48 hours. The seed has been planted very beautifully in a tray. This is this sprouting of the seeds. But when you compare it with 48 hours, this is exactly a control. That is no radiation treatment given to these samples. So the sprouting is very good. Now we are comparing this control with a 50 gray radiation dose as well as a 100 gray radiation dose. When we compare, again a 0 hour, this plate has been divided into 4. That is, diagonally placed are the bystander cell that is indirectly radiated, and diagonally again placed are the radiated cell that is directly radiation treated. The 0 hour, immediately after radiations, no effect obviously. Again followed by this, if we compare it with the control, the sprouting is good in control. When we compare it with the 50 gray radiation, the clear picture is taken. Followed by this, again a comparison is shown. This is the radiation part, therefore the sprouting is being affected in the seed, and this is a control, that is bystander part. So this is indirectly treated. That means these seeds has been kept in 2 parts, like bystander part that has not been directly radiated with radiations, and this is the another part that is directly treated with the radiation. So it has just been differentiated using a pen and a scale, that is line is drawn and effect is shown. So what can we conclude from the work? Yes, the very good point is that intensity of radiation affects the growth of the cells or growth of the plant. Yes, we have seen in the Allium sippa, we have seen in the Vigna radiata, we have the effect on enzymes also, that is catalases, SOD, superoxide dismutases. So these enzymes also show some effect of radiation.